Picture a boardroom in 2026. The CFO is demanding to know why engineering costs haven't dropped by 70% despite a massive rollout of AI coding agents. This is the productivity paradox currently hitting the industry. On one side, we have marketing claims from vendors like GitHub and OpenAI citing efficiency gains as high as 76%. On the other, empirical studies of enterprise environments show productivity stagnating or even declining due to the massive verification tax. In many cases, developers are writing code faster, but spending 3 times longer debugging the subtle architectural flaws these models introduce. We aren't seeing a revolution in delivery, we are seeing a shift in where the bottlenecks occur. If you are measuring productivity by lines of code, you are winning. If you are measuring it by shipped, stable features, you might be losing. By the end of this lecture, you will learn how to identify the specific context depth that turns AI speed into a long-term liability. But first, we must confront the data gap head-on. Why does the 70% figure feel so right to marketers, but so wrong to practitioners? We will uncover the hidden metrics of AI failure by the end of this lecture. To survive the post-hype era of 2026, organizations need a rigorous framework for measuring AI ROI that goes beyond gut feelings. As information management specialists, we must evaluate the entire software lifecycle. A 70% reduction in typing time is a vanity metric if it results in a 100% increase in technical debt. We need to measure the total cost of ownership of AI-generated code, including the cognitive load required for human-in-the-loop verification. Real productivity isn't about how fast the agent types. It's about the correctness-to-effort ratio. We will define 4 critical dimensions: verification cost, maintenance overhead, knowledge transfer, and structural integrity. This framework allows decision-makers to decide which projects are actually AI-ready and which should stay human-centric to avoid the spaghetti AI trap. Is your team measuring speed, or are they measuring value? This distinction is what separates successful AI adoption from a purely cosmetic upgrade. This way of thinking is essential because the way we calculate success determines our budget for the next decade. But where did that magical 70 number even come from? Next, we will explore the surprising origin of the productivity myth and how it was misinterpreted by the world. To understand why the 70% figure is misleading, we must first look at the metrics AI vendors use to claim victory. Most marketing materials rely heavily on acceptance rate and lines of code generated. For instance, if an AI suggests a block of 20 lines and the developer clicks tab to accept it, the vendor records this as a 100% success. However, as information management professionals, we know that code volume does not equal value. In many cases, AI generates verbose boilerplate that actually increases the surface area for bugs. Real productivity should be measured by the complexity of the problem solved, not the number of characters typed. By focusing on volume, vendors ignore the review tax, the time a developer spends reading and verifying that generated code to ensure it doesn't introduce security vulnerabilities or logic errors. This creates a dangerous incentive to favor quantity over quality in the development pipeline. But wait, how did these numbers escalate so quickly in just a few years? Let's trace the hype cycle timeline. In the early days of 2023, AI coding assistants were marketed with a modest 20% productivity boost, primarily focusing on unit test generation and basic documentation. By mid-2024, as agentic workflows became the buzzword, that number jumped to 40% or 50%. Fast forward to 2026, and we are seeing claims of 70% or even 10x developer productivity. This escalation isn't just about better models like GPT-5 or advanced Claude iterations. It's a competitive arms race among LLM providers to win enterprise contracts. They are moving the goalposts of what productivity means, shifting from time saved on a task to theoretical potential speed. In reality, while the models have become smarter at understanding context windows of up to 2 million tokens, the human cognitive limit for reviewing code remains unchanged. This widening gap between generation speed and review capacity is where the myth of 70% resides. This leads to a critical question. Why do so many developers still feel faster even when the data says otherwise? There is a psychological phenomenon at play here called perceived productivity. When a developer doesn't have to manually type out a complex regex or a repetitive CRUD controller, they feel a dopamine hit. They are moving their hands less and seeing code appear more quickly, which creates an illusion of high velocity. This is a form of survivorship bias. Remember the times the AI generated a perfect 50-line function in seconds, but we tend to discount the 20 minutes we spent debugging a subtle off-by-one error it introduced. In many 2026 enterprise surveys, developers report feeling twice as fast, yet the actual project delivery dates haven't moved. This discrepancy exists because coding the act of typing is only a small fraction of the software development lifecycle. We are optimizing the fastest part of the process while ignoring the bottlenecks. Does this feeling of speed actually translate to the metrics that matter for business? Let's compare traditional DORA metrics with these AI-driven claims to find the truth. When we analyze software engineering through the lens of DORA metrics, lead time, deployment frequency, MTTR, and change failure rate, the AI impact looks very different. While AI can reduce the coding time within a task, it often has no impact on lead time because the bottleneck remains in code review, security scanning, and QA. In fact, if AI-generated code is of lower quality, your change failure rate might actually increase, leading to more production incidents and a higher mean time to recovery, MTTR. By 2026, data suggests that while deployment frequency might stay the same, the rework required after a deployment has increased in teams that rely heavily on unverified AI suggestions. This misalignment occurs because AI metrics are local optimizations that fail to account for the global flow of value. If we improve one part of the pipe by 70%, but the rest is blocked, the output remains the same. But it gets worse. AI doesn't just fail to help. It can actually create more work through a phenomenon called code churn. Code churn is the silent killer of productivity in the AI era. It refers to code that is written and then quickly deleted or rewritten within a short period. In 2026, we are seeing a massive spike in churn rates among teams using advanced AI agents. The cycle usually looks like this. The developer prompts the AI, it generates a solution, the developer realizes it doesn't quite work, refactors it, prompts again, and eventually deletes half of the generated code to write a simpler version manually. This generation-deletion loop creates an illusion of activity. From a vendor's perspective, thousands of lines were produced, but from a project's perspective, the net progress is 0 or negative. This churn isn't just a waste of time, it degrades the mental model of a developer, who is now managing a Frankenstein codebase of mixed styles and fragmented logic. What does this mean for the long-term health of our software? The answer lies in the accumulation of a new kind of debt. To conclude this chapter, we must realize that the 70% productivity myth is a short-term mirage that often leads to long-term technical debt. While AI can accelerate the initial construction phase, it often ignores the maintenance phase, which accounts for 80% of a software system's total cost. In 2026, companies that chased the 70% metric are now finding themselves with codebases that are impossible to refactor because nobody, not even the AI, fully understands the interconnected logic of thousands of accepted snippets. We must shift our measurement framework from generation speed to maintainability index and reviewability. True productivity in the AI era is about how much value we can maintain with the least amount of code. In the next chapter, we will dive deeper into the hidden costs you'll face when trying to scale these AI tools across a large organization. It's not just about the subscription fee. Get ready to discuss the hidden costs of AI coding. In the hype of 70% productivity gains, the industry often overlooks the verification tax. When an AI generates 100 lines of code in seconds, the developer's role shifts from a creator to an auditor. Cognitive load theory suggests that reviewing code written by another entity, especially a non-human one, is significantly more taxing than writing it yourself. This is because you must reverse engineer the AI's logic to ensure it aligns with edge cases and security protocols. As we look toward 2026, the bottleneck in software production is no longer typing speed but validation throughput. If a developer spends 20 minutes scrutinizing a generated snippet to prevent a production outage, the perceived time saved on typing is quickly liquidated by the intense mental effort required for verification. But what happens when that quick fix contains a logic bomb that only triggers under specific production loads? This is where the debugging nightmare truly begins. The debugging loop in the AI era has become a deceptive cycle. When an AI hallucinates a non-existent API or uses a deprecated library version, the resulting error is often subtle. A developer might spend hours chasing a ghost in the machine that they wouldn't have created if they wrote the code manually. We call this stochastic debugging. In many real-world 2024-2025 benchmarks, developers reported that while the first 80% of the task was completed in minutes, the final 20% fixing the subtle regressions introduced by the AI took longer than the entire manual process would have. This creates a productivity trap where the project appears to be moving fast on the surface, but the underlying technical debt is accumulating at an exponential rate. Hey, if you think debugging your own code is hard, wait until you have to debug code you didn't even write. The architectural consequences are even more severe. One of the most critical failings of current LLMs is the limited context window and the lack of global architectural awareness. Human thinks systems, AI thinks in snippets. While an AI can perfectly generate a single function, it often fails to understand how that function impacts the overall system state or adheres to specific design patterns like clean architecture or domain-driven design. This leads to architectural drift, where the code base becomes a patchwork of inconsistent styles. A developer might use AI to speed up a feature, only to find that the AI introduced a direct dependency that violates the project's layering rules. By 2026, managing this structural integrity will be the primary challenge for tech leads. Teaser, this lack of global vision leads to a specific type of failure that documentation alone cannot fix, something we call logic drift. As AI-generated code floods our repositories, we are witnessing logic drift. This occurs when the code's behavior slowly diverges from the original intent, because developers are accepting suggestions without fully documenting why. In a manual workflow, the act of writing code forces a mental model that is naturally reflected in documentation and comments. With AI, that mental step is often bypassed. The result is a project where the source of truth is buried under layers of machine-generated boilerplate that no one fully understands. This creates a massive risk for future maintenance. When the original developer leaves, the AI-generated logic remains as a black box. Question: does this mean AI is only for juniors who just need to get things working? The data suggests a much more complex relationship between experience and AI. The 70% productivity myth is often fueled by data from junior developers. For a junior, AI is a massive force multiplier because their primary bottleneck is syntax and basic boilerplate. AI helps them reach a functional baseline much faster. However, for senior developers, the story is different. Seniors spend most of their time on high-level decision-making, trade-off analysis, and system design areas where current AI still struggles. In fact, some studies show that AI can actually hinder senior performance by introducing distraction noise and requiring more time for review than it saves in typing. The skill leveling effect is real, but it's not a uniform lift across the board. Teaser, there's a darker side to this efficiency gain for juniors, the potential erosion of the fundamental learning process. The most significant hidden cost is the potential loss of internalized knowledge. Software engineering has traditionally been an apprenticeship. By struggling through bugs, developers build the intuition required for high-level system design. If we outsource that struggle to an AI, we risk creating a generation of developers who can generate code but cannot reason about it. This apprenticeship crisis could lead to a shortage of seniors who truly understand the underlying mechanics of software by 2030. We must balance the immediate speed of AI with the long-term need for deep expertise. Bridge understanding these hidden costs is just the first step. Next, we need to look at the cold, hard data to see if the productivity numbers actually hold up in 2026. Let's move to Chapter 4, Reality Check, Data-Ended Benchmarks. The initial excitement around AI coding has hit a significant wall in the open source community. Maintainers of major repositories are reporting a surge in what we call garbage PRs, pull requests generated in seconds by AI that lack architectural context. One prominent maintainer noted that while AI can write code, it cannot read the existing 3 years of technical debt or understand why a specific pattern was chosen over another. This creates review debt, where the time human maintainers spend correcting AI hallucinations far exceeds the time it would have taken to write the code manually. The backlash on platforms like Hacker News isn't just noise. It's a structural warning that the cost of verification is becoming the new tax on productivity. We are seeing a shift where lines of code is no longer a metric of success, but a liability if those lines aren't deeply understood. But is this just an open source problem? Let's look at the hard numbers from enterprise repositories to see if professional teams are faring any better. When we analyze large-scale commit data from 2024 and 2025, a disturbing trend emerges. While the frequency of commits has increased by nearly 40% in AI-enabled teams, the revert rate and code churn, the percentage of code that is deleted or rewritten within 2 weeks, has spiked significantly. In some enterprise environments, the net code impact is actually lower than the pre-AI era because developers are moving faster but in the wrong directions. We see U-shaped quality curves. Juniors are producing more but lower quality, while seniors are spending their gains on fixing junior outputs. The data suggests that coding speed is a vanity metric. What matters is feature lead time, which hasn't seen the 70% improvement vendors promised. Instead, we see a modest 10-15% gain in settled production-ready code. This discrepancy leads us to a critical realization about the limits of automation. More code, more bugs. But why does the speed drop even further as we add more AI tools? In software economics, we talk about the law of diminishing returns. In the context of AI, this is the automation trap. Initially, using AI for simple tasks like writing a regex or a basic utility function gives you a 100% boost for that specific minute. However, as the complexity of the task increases, the marginal utility of the AI drops. Why? Because the cognitive load of verifying the AI's logic grows exponentially. When an AI generates a 50-line complex algorithm, the developer must mentally execute every line to ensure there are no subtle security flaws or edge case failures. This is the verification tax. Once the AI handles the easy 20% of the work, the remaining 80% of the logic, the integration, and the security remains just as hard as before, but now you have the added burden of checking someone else's, or something else's, work. If the AI isn't the problem, then where exactly is the traffic jam in our delivery pipeline? To understand why the 70% myth fails, we must look at the entire software delivery lifecycle, SDLC. Coding, the act of typing syntax, typically accounts for only 15% to 20% of a developer's total time. Even if AI makes the typing phase 1000% faster, the rest of the pipeline remains unchanged. Bottlenecks are human-centric: requirement clarification, architectural design, security audits, and deployment approvals. In fact, AI often creates a buffer bloat at the pull request stage. We generate code faster than the CI/CD pipeline can test it or the lead engineer can review it. This creates a backlog that actually slows down the time to market. High-performing teams realize that the goal isn't more code per hour, but more value per release. This shift in perspective is what separates the hype-driven teams from the truly productive ones. Now, let's look at the outliers, those rare teams that actually succeed in extracting value. So who is actually winning with AI? It's not the teams trying to automate everything, but the ones using AI for surgical strikes. High-performing teams focus AI on 3 specific areas: unit test generation, boilerplate for new services, and documentation. For instance, generating 50 edge case unit tests for a stable function is a perfect use case because the cost of failure is low and the verification is automated by the test runner itself. They also use AI to explain legacy code during the discovery phase, which reduces the time spent in code archaeology. These teams don't ask AI to write the feature, they ask AI to build the scaffolding so they can focus on the core business logic. This selective application ensures that the verification tax remains low while the utility stays high. The difference between success and failure often comes down to one thing: the integration strategy. To wrap up this reality check, the 70% myth is based on a narrow definition of productivity that ignores the downstream costs of maintenance and review. Real-world high performers treat AI as a junior partner that needs clear boundaries and rigorous oversight. They prioritize workflow integration over token generation. They measure success by how much less code they have to write to solve a problem, not how much more. By 2026, the teams that thrive will be those that have moved past the hype and built robust measurement frameworks to track the actual impact on their specific tech stack. We've seen the data, we've seen the backlash, and we've identified the traps. Data shows the 70% myth is just that, a myth. But how do we measure the real impact in our own projects and prove it to stakeholders? That's what we'll solve in the next chapter: strategic adoption and measurement. When vendors claim a 70% productivity boost, they usually look at the time spent typing characters into an editor. But as software productivity analysts, we must look at the net productivity gain. A true ROI calculation must account for the hidden shadow time. We define the formula as the time saved in initial drafting minus the sum of review time, debugging time for hallucinations, and long-term maintenance costs. In many enterprise projects, we see that while the drafting phase is 5x faster, the verification phase can expand by 3x. Because the developer didn't actually write the logic and struggles to find subtle edge case bugs. To get a real measurement, you need to track cycle time from issue open to production deploy, not just lines of code per hour. If your review bottlenecks are growing, your AI adoption is actually slowing you down. But how do we measure the impact on the humans behind the keyboard? Let's look at the qualitative side of the equation. Quantitative metrics like lead time are essential, but they don't capture the whole reality of the developer experience. We need to balance these with developer joy and burnout rates. Interestingly, some teams report high productivity but lower job satisfaction because they feel like glorified copy-pasters rather than creators. This leads to reviewer fatigue, where senior developers become overwhelmed by the sheer volume of AI-generated pull requests. Effective measurement should include the SPACE framework looking at satisfaction, performance, activity, communication, and efficiency. If developer satisfaction drops, your long-term retention will suffer, negating any short-term speed gains from AI. We must ensure AI is used to eliminate drudgery, not to turn development into a high-speed assembly line that ignores architectural integrity. Does this mean we should stop using AI? Not at all. It means we need better guardrails. To safely scale AI adoption, you need a rigorous governance framework. You cannot treat AI-generated code as trusted code. Every line must go through a verification pipeline that includes automated security audits and mandatory human oversight. This means updating your definition of done, DoD. Your checklist should now specifically include checks for hard-coded secrets, package hallucinations, and license compliance for the training data utilized by the AI. As an information management professional engineer would advise, you need to establish verification gates that AI cannot bypass. Organizations that ignore this see a 20% spike in security vulnerabilities within the first 6 months of AI adoption. The goal is to move from trust but verify to verify, then merge. This framework ensures that the speed of AI doesn't become the downfall of your system's stability. Now, let's look forward. How will this measurement strategy evolve as we move toward 2026? By 2026, we will move past simple autocomplete and enter the era of agentic verification. In this stage, AI won't just suggest a function. It will operate as an autonomous agent that drafts the code, writes the unit tests, runs them in a sandbox, and only presents the developer with a proven solution. This shift changes our measurement from coding speed to agent management efficiency. We are seeing the rise of multi-agent orchestration, where one agent writes the feature while another agent acts as a red team security auditor. The 70% myth might finally become a reality, not because the AI writes faster, but because the verification loop is automated. This will require teams to build robust CI/CD infrastructures that can handle high-frequency agentic commits. But wait, where is all this thinking happening, in the cloud or on your own servers? As we head toward 2026, the battle between SaaS LLMs and local models will intensify. While GPT-4 and its successors offer massive reasoning power, enterprise security and the need for deep context are driving a shift toward local, fine-tuned small language models, SLMs. A generic model doesn't know your company's proprietary 10-year-old legacy API or your specific security protocols. By fine-tuning local models on your own codebase, you reduce the review overhead because the AI actually understands your internal environment. Local models also solve the data privacy hurdle that currently prevents many financial and healthcare sectors from realizing the full 70% to productivity potential. The future isn't about the biggest model, it's about the model that fits your context best. But even with the best local models, the role of the developer is fundamentally changing. Are you ready for the transition? The most critical takeaway for 2026 is the birth of the new senior developer. In this new world, coding is no longer a manual craft but an auditing skill. The senior developer of the future is an architect auditor who knows how to orchestrate AI agents, validate complex system interactions, and maintain the human-in-the-loop integrity. We must focus on reskilling our teams not in how to write code, but in how to read and verify code at scale. Productivity won't come from typing faster, but from making better architectural decisions that AI can then execute. If you stay as just a coder, you will be replaced by the myth. If you become a verifier, you will lead the industry. In our final chapter, we will wrap up everything we've learned and provide your final roadmap for moving beyond the 70% myth to actual, sustainable impact. Let's see what the conclusion holds. As we wrap up our analysis of the 70% productivity myth, it is time to face the reality of your own development environment. Many teams fall into the trap of pseudo-productivity, where a high volume of AI-generated code masks a growing mountain of technical debt. To determine if your current AI integration is healthy, you must look for specific red flags and green flags. A major red flag is when the review to or time ratio exceeds 1:1. If senior engineers spend more time debugging LLM hallucinations than they would have spent writing the code themselves, your actual productivity is negative. Conversely, a green flag is the reduction of boilerplate fatigue and an increase in unit test coverage without sacrificing architectural integrity. By 2026, the decision to scale AI tools shouldn't be based on vendor marketing hype, but on these internal telemetry metrics that measure the true cognitive load of your engineering team. If you ignore these signs, you risk a long-term code quality collapse that no AI can fix. But how do we maintain this balance in a landscape where models change every 6 months? Let's look at the final strategy for continuous monitoring. The journey into AI-augmented development doesn't end with the initial rollout. By 2026, the competitive edge won't come from simply having an AI assistant. Every company will have one. The real winners will be those who master continuous productivity monitoring. You need to move beyond vanity metrics like lines of code or total suggestions accepted. Instead, focus on DORA metrics like lead time for changes and change failure rate. Ask yourself, is the AI helping us ship value faster, or is it just filling our repositories with more lines that require expensive maintenance? High-performing teams treat AI models as junior developers that require strict linting, automated testing, and constant human oversight. We must foster a culture where human-in-the-loop isn't viewed as a bottleneck, but as an essential quality gate. Remember, the 70% figure is a theoretical ceiling in a vacuum. Real-world success is measured by sustainable velocity and the happiness of your developers. This concludes our deep dive into the reality of AI-augmented development. Now, it is time for you to apply these measurement frameworks to your own CI/CD pipelines to separate the signal from the noise.